Hello, everyone. This is our CGT 313 video case study project. I am Shayne Piskule, and my partner is Shayne Malone. Quick introduction. I'm a fourth-year student studying virtual product integration and building information modeling.
Hi, I'm Shayne Malone. I'm also a fourth-year student studying for visual design engineering and product lifecycle management.
So there's three concepts to understand that we learned in CGT 313. The first of which being product lifecycle management. Product lifecycle management, or PLM, is an integrated information-driven approach comprised of people, processes, and practices, and technology to all aspects of product's life and its environment, from basically its design to manufacture through deployment and maintenance. Next, we have virtual product integration. Virtual product integration, or VPI, is the use of digital representation to define a product. Products are created using trusted processes that focus on information technology and how the product is used. Lastly, we have digital enterprise. The digital enterprise is the interconnected system and data repository across various domains within a given organization that also extend to external systems and data repositories that allow for free flow of data across a digital backbone. All of this might seem like a lot to take in, but we're going to go a little bit more in depth on the slides next. So let's talk about product lifecycle management. What is it? Oracle defines product lifecycle management as the strategic process of managing the complete journey of a product from initial ideation, development, service, and disposal, or an easy way to put it, managing everything involved with a product from cradle to grave. The picture here on the right is a great example of the PLM cycle. The process starts with concept and design, where ideas are put on paper. Next, it will move to the development phase, and the product will start being mass produced. After its launch, the product may inevitably have some defects that need to be patched, and finally, product retirement. It is common for products to go out of use, especially in our fast-changing, technology-driven world. Competition will always drive the next biggest idea. My personal favorite to think about is the way we watch movies. VHS was around when I was first born, but it went through its own PLM cycle and shifted towards CDs. And now even CDs are getting replaced with streaming services like Netflix and Hulu. This is just an exaggerated example, but PLM will focus on the reiteration of a product within a company from start to finish. Here's another great example of PLM. Jimmy John's, the well-established sandwich shop known for its freaky fast, freaky good service. Jimmy John's surprisingly utilizes PLM every day. Now, before we get started, PLM scope includes four big forms of management: product data management, supply chain management, enterprise resource planning, and customer relations management. Let's look into product data management. That delicious looking sandwich is an example of Jimmy John's product. The company needs to account for what ingredients are needed and how to correctly prepare the sandwich and any health conditions that may be important to know when preparing the food. Next, there is supply chain management. This is related to all of the food packaging as well as means of securing the product. The process is very important to have nailed to a T, as customers want the same level of experience every time. Enterprise resource planning, related to the behind the scenes work of the company, owning franchises, payroll, and even obtaining the products for the sandwich. This work is very important in regards to the functionality of the business. No store means no workers, which means no sandwiches, which definitely won't bring in any customers. And speaking of customers, the final form of management is customer relations management. This is the feedback and the customer service surveys the company handles. Not only that, but the advertisement of the product. A business needs to have happy consumers in order to stay afloat. These four topics all encompass the entire PLM process, most of which people don't even consider, but there is a lot to comprehend and understand to run a successful company. We learned how to properly install these programs, which serve similar functions but operate very differently. Team Center is the first. Team Center is a thick client, meaning the software is locally installed, holds a lot of information, and takes up a lot of storage. It is also connected with NX, a Siemens 3D modeling software. However, user interface could use a few upgrades. Eris, on the other hand, was a thin client, meaning users could connect remotely into a separate server or a data center. This saves storage space on your OS and allows data to be stored elsewhere. The program has a very clean user interface and is very adaptable for any kind of company. Eris has been a huge competitor to their counterpart Teamcenter because this way of operating is so new and efficient. Let's talk about virtual product integration. Surprisingly, VPI is used in just about every day. You have probably seen it without even realizing. VPI is used to represent a physical product, typically in the design phase of production. It is a lot cheaper to draft and design the product on the computer than to hand create the product and find mistakes throughout. By then, you have wasted materials and money, so no one's happy. 3D modeling programs are best at creating a product fast and allowing for change to happen instantaneously. Not only that, but 3D modeling programs are getting so advanced that they're even allowing for simulations. The picture on the right is of two cars crashing into each other to test the impact of the material and the car structure, essentially having the ability to save someone's life with this knowledge. And lastly, what I've seen more and more used today is the way VPI is being used to sell a product. Companies are currently adding a view in 3D button to online shopping to appeal to more customers' interests. Chances are next time you are online shopping, you will see that button when viewing a product. VPI encompasses a lot, but it is easy to understand once you recognize its importance. What is the digital enterprise? Siemens, the creator of Teamcenter, defines the digital enterprise as a business that has encompassed a digitalization strategy, aka digital transformation, to fully incorporate digital tools and technologies across all aspects of their operation, from ideation through realization to utilization. Some great examples of that could be how UPS uses handheld tracking systems to keep account for all their package locations. Another simple one is what a company might use to keep track of their accounting. And as a last example, since I will be going into the construction industry, I thought it would be interesting to mention the digitization of blueprints. It is becoming more and more common for foremen and superintendents on the job to be carrying around iPads to review building specifications. Amazon Web Service is a great example of the digital enterprise. Amazon has the best database in place to create a uniform company information flow. Quality assurance, predictive maintenance, and production optimization are some of the best services utilized, to name a few.
In order to better understand the capabilities of the digital enterprise, it's important to identify more of its core components. The digital thread is the name given to the process of using the digital enterprise and its interconnected facets in any certain instance. It is the path through which information is gathered, problems are solved, decisions are made in regards to a specific business decision. This could mean accessing legacy data of obsolete products from a development partner to reference during future product development, or even solving supply chain issues by requesting manufacturing analytics of producers. As exemplified by General Electric's digital thread diagram shown here, the purpose and therefore definition of the digital thread are flexible. The digital thread allows for there to be what is known as the digital twin. As the U.S. Air Force Global Science Technology Division stated in 2013, the digital twin is the creation and use of a digital surrogate of a material system to allow dynamic, real-time assessment of the system's current and future capabilities to inform decision, acquisition, and etc. A digital twin is an aspect of the larger virtual product integration concept, and as such, enables all the previously stated advantages: simulation testing and fully digital iterative design, reducing cost, and increasing development efficiency. With that said, there are many reasons companies choose to implement PLM, PI, and digital enterprise processes. These include an increase in the efficiency of metric communication during development cycles, properly defined roles for team members to inhabit and work in, reliable record keeping, company data, past, present, and future, overall ease of access to information, and all the cost savings associated with it aforementioned. Even still, companies shy away from fully digital transformation. This is often because of lack of experience with these difficulty in transforming their processes, and a perception that all of these changes won't be worthwhile. While understandable, any size company can take advantage of these tools with the right approach and mindset. PLM requires companies to plan for their future production while accounting for their past decisions. VPI requires accurate data and descriptions to be digitally represented. The digital enterprise itself requires the willingness to problem solve using these digital tools. For successful implementation, Full understanding of these concepts and full commitment to using them is necessary. An example of implementing these strategies well is that of the company Fiat and their development of the Fiat Bravo. A full, optimized digital transformation took place, and the result was a shortened development cycle, development costs, and overall improvements to the cars. In regards to the future, there are a few things that engineers can expect. In essence, there will be an ease of data communication and retrieval through the use of PLM software like Teamcenter and Eris. Secondly, there will be more digital product testing and design through VPI incentivizing digital product replication and development through CAD software like SolidWorks and NX. And thirdly, further digital transformation of business processes will take place. Through the digital enterprise, a network of information will be created, allowing for problem solving to take place virtually instead of fully physically.
So applying these skills after college. I will be going into the construction industry after college, where it will be a huge help to have this MBSE mentality. By knowing these concepts, I will be able to apply it to situations like keeping track of projects, record keeping, conversations I've had with clients, and even having the ability to establish best practices when I move on to the next job site. I have already had a little experience with these concepts without even knowing.
In regards to me applying these skills after college, I intend to go into the field of product design after I graduate, a field where MBSC and the digital enterprise are already well integrated. Learning these ideas makes me better ready to tackle the complicated world of industry, where I can design based off data available to me, and those designs can be iterated and communicated to my team members due to the digital backbone that's been established. For this course, I had experience in design, but little in the way of design communication. This gives me a new important tool in my kit. Thank you for listening. And here are our references.